Today we are going to start with an introduction to the distributive property, focusing on just numerical expressions and not algebraic. So the first thing we're going to do is look at a visual of this. So what we're going to do to begin is we're going to draw two rectangles that have the same width but different lengths. So for example, I'm going to draw one rectangle that is 3 units by 4 units. So I'm just going to use my grid here. So I have 3 here and 4 here. Then I'm going to draw another rectangle, and I'm going to keep that 3, but I'm going to go ahead and make that 1, 2, 3, 4, 5, 6, that length. Okay, so there's my two rectangles. So what we're going to do down here is write an expression for the total area. We know to find the area of a rectangle, we take the length times the width. So to do that, I would be taking 3 times 4 to find this area, and 3 times 6 to find this area. So that would be an expression. Now, if we wanted to physically cut out these rectangles, we could, and we could rearrange them so that they were side by side, kind of put them together. So what would happen, it would now look like this. Squish them together like this. So now I have 3 on this side, but I have my 4 plus the 6 here. We can still find the area the same way. 3 times my length here. So 3 times 4 plus 6. So we just use the distributive property to find the area of these rectangles. So what's happening is we have two expressions that are now equivalent to each other because they represent the same area. So in part D, it asks if the expressions can be set equal to each other, and again I say yes, because both expressions represent the same area. The area of these two is the same as the area of these two. Okay, so I turned my page over, and now we're going to use kind of that same thinking, that same strategy, to look at some mental math strategies to solve problems such as this, 23 times 6. We're going to kind of use partial products in a sense, and this is how I tend to multiply in my head pretty often. So what we're going to do for 23 times 6, I'm going to think of this as 20 and 3. So if I break up this 23 into 20 and 3, the first thing I'm going to do is multiply 20 and 6. Okay, that's going to give me 2 times 6, that's going to give me 12, and then I add my 0 to get 120. Then I'm going to take the 3 from the 23. So this 23, I'm thinking of it as 20 plus 3. So I did 20 and 6. Now I'm going to multiply the 3 and 6. That's going to give me 18. And then I'm going to add those two together. 120 plus 18, I end up with 138. Go ahead and try that method with the next 4 problems below. Pause your video, give it a try, and then unpause to check your work. All right, go ahead and check your products there. The next thing we're going to do now is apply this a little bit more formally and take this strategy and use it as the distributive property. So now I'm going to say this, what we're going to do now is using the distributive property. We're still using some mental math strategies, but we're going to apply this formal property. So we're going to use some of the same problems here. I'm going to start with 6 times 23. So since we're using the same problem we started with above, we should end up with the same product. So 6 times 23. I'm going to take that 6 times 23, And the first thing I'm going to do is write 23 as the sum of 20 and 3. Okay, so here's what this looks like. I'm going to take 6 times, and instead of 23, I'm going to write this as 20 plus 3. So I have 6 times 23. My first step was writing it as a sum. Okay. Now, this next part is where we are using the distributive property. So here's what I'm going to do. I'm going to take that 6 and distribute it over the sum. So what that looks like, I now have 6 times 20, 6 times 20. We're adding the 6 times 3. So it's just like adding those two rectangles or using our mental math strategies like we did above. But we can use this fancy word, distribute. What we did was distribute the 6 over the sum. So that's where we get the term distribute. We're talking about the distributive property. So now we're just going to go ahead and find the products. That's going to be our next step. And then lastly, we will add. So my product of 6 times 20, that becomes 120. 6 times 3 becomes 18. There's my 138. Same product we got above, we just used a more formal process with the distributive property. Go ahead and try, pause your video, try that with the last one. You don't need to write out the steps in words, but you do need to show your steps with the distributive property here. Then unpause and check your work. All right, go ahead and check your work on that last one there. All right, and now I'm going to have you try some more on your own here. So if you flip it over, there are 5 more. I want you to try these on your own. So again, pause your video, give it a shot on your own, and then you can unpause and check your work. All right, so 8 times 26, I did 8 times 20, 8 times 6, 208. 20 times 19, there are 2 different processes that I'm showing here. So you could do 20 times 10 and 20 times 9 and add them together. However, another method would be to take my 20 times 19 and instead of 10 plus 9, my 19 can be 20 minus 1. So then I have 20 times 20 minus 20 times 1. Just a different way to think about it. You're going to get the same product. Okay, 40 times 29, I'm sorry. Again, 40 times 20 and 40 times 9, add them together. Or the other option is 40 times 30 minus 40 times 1. Same product. Letter F, 25 times 39. Again, you could do 25 times 30 plus 25 times 9. I went ahead and just did the subtraction because 40 minus 1 seemed a little bit easier to work with than 30 plus 9 for me. And letter G, again, you could do 15 times 40 and 50 plus 15 times 7. This one's a little bit different. We're not subtracting 1, we're subtracting 3 because the idea is I want that second portion to represent 47. So 50 minus 3 is going to give me that 47. So that's why I did 50 minus 3 there.